Alright, so this video we're going to look at the nth root theorem. This is the second example. In the first example we found the fourth root. This was the example that we worked. If you want to check this one out, that's the first example. Find all fourth roots of this one. Alright, so this will be the second example. So if n is any positive integer r, if n is any positive integer, r is a positive real number, and theta is in degrees, then the non-zero complex number r cosine theta plus I sine theta has exactly n distinct nth roots given by this. So the complex number, notice it's in trigonometric form here. Okay, so sometimes they might give it to you in rectangular form, x plus yi, or you might have seen it a plus bi, same thing. Okay, this is in rectangular form, but notice to use this nth root theorem, your complex number has to be in trigonometric form. Okay, and we have n distinct nth roots given by this, the nth root of r times cosine theta plus 360 times k over n plus I sine theta plus 360 times k over n. Now, well, and k is 0, 1, 2, all the way to n minus 1. All right, so, and the other thing I want to say about this, that this right here is when it's in degrees. You can as easily do it in radians. It's just the 360 would be 2 pi instead of 360 if you're doing it in radians. I'm gonna do the example in degrees. If you want to do it in radians, it's the same thing. All right, so let's go ahead and get started. Now, the other thing I want to show you too, because it's going to make our work a little shorter. This right here can also be written as the nth root of r times cis of theta plus 360 times k over n. All this is an abbreviated form of this. You've probably seen it in your trig class that this r cosine theta, r times cosine theta plus I sine theta can be written as this. It's just an abbreviated form, and that's how I'm going to write this when we're working the example, so I don't have to write all of this, just have to write it one time, just abbreviated form. Alright, so let's look at our example. Alright, so here we want to find the two square roots of 4i. Alright, so notice this is in rectangular form. We need to convert it to trigonometric form. So I have videos on that if you need to check that out. I'll go over it here, but it'll be a little quicker than the other videos that I actually show you how to do it. Alright, so remember, if we have a complex number and it's in this form, x plus y times I, okay, well, remember, we need to get it in this form, r times cosine theta plus I sine theta. Okay, so I need r. Well, remember, r is the square root of x squared plus y squared. And for theta, we can find that by using the fact tangent theta is equal to y over x. Okay. All right, so here we have 4i. Well, remember also that 4i, that's the same thing as 0 plus 4i. So in this case, x is 0, y is 4. So let's go ahead and find r. So r is the square root of 0 squared plus 4 squared. And so that's just going to give us r is 4. Now, look at this. Tangent theta, that would be what? 4 over 0. That's undefined. Okay, so we can't use tangent theta is equal to y over x. But what we can do is we can graph it. Okay, remember, this is the real axis, this is the imaginary axis, this is the real part, this is the imaginary part. So I'm at 0, 4. Okay, see, x is 0, the real part is 0, the imaginary part is 4, so we're right there. Okay, so this would be 0, 4i, and this is what? 90 degrees. So there's theta. All right, so 4i can be written as, where is it? R, which is 4, times cosine theta, which is 90 degrees, plus I sine theta, which is 90 degrees. So this is the trigonometric form. Okay, so let's go ahead and write down the formula. So it's what? It's the nth root of r, and I'm going to write it in the abbreviated form. I'm going to write it in this form here. Okay, instead of writing all that out, they're the same thing. This just means cosine of this plus I sine of this. Okay, all right. So this is going to be times CIS, and that's going to be theta plus 360 times K over N. Okay. All right. So if you look at this, you can see we have R and we have theta. Well, N is equal to 2, the square roots. Okay, there's 2, remember, there's 2 distinct nth roots. In this case, the nth is square roots, 2. So there's 2 square roots. So n is 2, and k is equal to 0, 1. Now where did I get that from? If you watched the first video, you saw me explain it. But k is equal to from 0 to n minus 1. Well, in this case, n in our problem is 2, so that's 2 minus 1, which is 1. So k would be 0 all the way to 1. All right, now, well, we've got everything. So now all we have to do is evaluate this for k equals 0 and evaluate this for k equals 1. Okay, so let's see. So when k is equal to 0, okay, we've got the nth root of r, so that's the square root. N is 2, and remember, square root is understood to be 2 of r. R is 4 times theta, in this case is 90, plus 360 times, and for this one, k is 0 over n. And so that would be 2, square root of 4 is 2, and that would be 45 degrees. So there is 1 square root of it. Now let's find the other one. So k equals 1. Okay, k equals 1. So for this, I've got square root of 4. Remember, I'm using the abbreviated form. That's 90 plus 360 times, and in this case, k is 1 over n, which is 2. Right? So the square root of 4 is 2, and then that's going to be, let's see, 90 plus 360, and divide that by 2. That is 225. And this would be your other square root. Okay, so your answers are these. And let me say this, you can, okay, you can convert this to rectangular form. Okay, and if you do convert it to rectangular form, I'm not going to show you how to do it. I mean, it's just 2 times, and then it's the cosine of 45 plus I sine 45. So you would actually take the cosine of 45 and the sine of 45. I mean, I'll show you on this one, but so that would be 2 times cosine 45 plus I times sine of 45 degrees. Well, that's 2 times the cosine of 45. Well, remember that's square root of 2 over 2 plus I times sine of 45, which is square root of 2 over 2. And then if I distribute the 2, see the 2's in the bottom cancel, so that would be square root of 2 plus I square root of 2. Okay, so this would be this one in rectangular form, and then this one, well, that would just be negative square root of 2 plus, well, not plus, minus I square root of 2. And that would be this one in rectangular form. I got videos on how to do that, go from trig form to rectangular form. Complex numbers, you can check those out. Alright, so, well, that's what you do. So basically all it is making sure that your complex number is in trigonometric form. So you have to convert it. And I have videos on that if you need to watch those. And then you just figure out what k is. Well, k is, if you're, in this case, the square root, so n is 2, so k goes from 0 to 2 minus 1, which is 1. In the other video, we had a fourth root, so k went from 0 to 4 minus 1, so 0, 1, 2, and 3. All right, and then all you do is just evaluate this at each value of k, plugging in r, theta, and n. R, theta, and n are going to remain the same in all. The only thing that's going to change is the k value. All right, so I hope that helped. Give me a like, share, subscribe, and thanks for watching.